First, I hope everybody can hear me. This has been just a fascinating kind of workshop today, just to hear all the different ways that people are coming at the challenge of agents and some of the opportunity around it. If I could quickly ground people, I think probably what you heard from IBM and what you heard from Salesforce is probably along the same vein that we're going to be talking about over the next 14 and a half minutes or so. LLMware, we launched in open source around 18 months ago. We launched our development framework. And from the very beginning, what we were grounded in was small language models. So you could do a lot of things around RAG and around agents, but it was always how do you do this locally, privately? And rather than think about the biggest model that you could use, we've always been focused on what's the smallest model that you can use. I'm not going to use any PowerPoint. I'm actually just going to show you a demo and really try to bring to life some of the things that we've been doing around agents. Some of our principles, and we mentioned this actually on our last workshop, I guess a couple of months ago. Um, no token charges. We don't like token charges. We don't think they're sustainable. We think the marginal price of inferencing, the market price that people are going to pay for inferencing is going to zero. So get off per token charges because we don't believe that they're ultimately sustainable from an ROI and an enterprise point of view. Second, it can run entirely private. So other than the Zoom link, which is in fact consuming some NPU resources on my machine, so may run a little bit slower, you can actually run everything that I'm about to show you in an air-gapped environment running entirely on an edge device. Finally, and I think IBM, some of their comments really hit on this really, really beautifully. You can't approach this the same way with a 200 billion parameter model when you start scaling this down to a 1 to 14 billion parameter model. So part of the art of this is how do you think about decomposing tasks and really aligning them so that you can get the best out of small models. Jean-Marc, as you said in one of your earlier comments, basically you can replicate anything that you can do with a big model, you can replicate it with a bunch of small models. All right. What you see in front of me is actually Model HQ. This is our commercial offering that we're going to be launching in about 10 days. This is an overnight build of the code, and we're going to dive right in. And what I want to start off by showing you is just one capability of the product, which is really around document-centric, knowledge-centric, research-centric agent-based processes, again, running entirely privately and locally. The one thing I do want to mention up front that I haven't heard today, and I think it's one of the best kept secrets actually in AI, is the emergence of the AI PC. And this is an initiative that Microsoft originally launched around 18 months ago. Intel, Qualcomm, AMD have been building amazing chips that are coming to laptops soon. This is an Intel Lunar Lake laptop. And again, you're going to see some of the benefits in terms of the performance that you're able to realize, again, locally and on the edge. All right, so these are a few pre-built
Yeah,
agents.
you're not sharing your screen yet. Is that by intent?
Oh no, it actually says sharing screen.
Yeah, I think he's sharing,
Oh,
Jeff.
so okay, good. All right.
Okay, so you can see my screen. You can see the agent menu, Asif.
Yes, yes, you can see
Okay,
a screen.
all right, good, good. Got me scared. I'm just going to run through a quick process. I'm going to explain the process, show it to you, and then most importantly, I'm going to show you actually how we build it. So this process is one I just built this morning, and it's very representative of what we see as kind of a canonical agent case. You have some inbound, some intake from a customer. It could be a voice transcript. It could be a message that they've left you. It could be an email. It could be a social media post. But you want to take some unstructured text as an input. You want to run it through then a series of analyses to run some intent behind it, sentiment, emotions, and ratings. What's the emotional content of this message? You want to be able to extract and answer some questions. Who is the customer? What is the problem that they have? And then what we're going to do is we're actually, in the course of this process, we're going to take a CSV that's an extract from a database. We're going to build a database table. We're then going to, in natural language, query the database table, pulling information that we've received earlier in the process. You're going to see the whole thing running on the screen, and then we're going to get all the structured output of the analysis of this at the end. All right, so let me go ahead and let's run this. Oops, sorry. All right, this is just a representative. This could have been a voicemail that was left. It could have been an email, customer calling in, chock full of some data points that you want to be able to extract. And also one of the most important things you want to figure out is, hey, is this customer happy? Do they have a problem? Like how urgent, how big of a problem is this? So let's go ahead and let's start running this process. Again, all of this is running locally. And what we're doing is we're actually running 5 small specialized models that are all running on device. They're actually running on the Intel Lunar Lake GPU really, really fast. And each of these are, in effect, we didn't call them action models, but they're essentially action models. They give structured output in response to inputs. They don't work with prompts, meaning all of these essentially are a function that operates on a piece of text and then yields a structured output. We then have 2 services, as I mentioned, the build table and the query table. We're now stepping through the process. We've loaded all of these models in memory. Each of the models then have gone to work on that text input. Sentiment coming in negative, customer is annoyed. On a scale of 1 to 5, customer is not happy with us. We then extracted the customer name and the customer issue. Product isn't working. And then we went ahead and we actually built this table, and I'll actually show how we did that. We built a table of our top customers. We then queried that table with the customer name that we derived in step 5, Susan Sorensen, looked her up in this table that we just created to identify that she's a silver customer and her spend was 112. So thankfully, this is not a big customer, but it does help to complete the process. And something that we see as one of the most common things that people are looking to do, take some kind of input, extract some lookup keys, run some type of secondary lookup then, whether it's a web resource, a RAG resource, or a database, and then pull that information into the context so you can start to evaluate and get a complete picture of it. So at the end of this process, again, all of the keys then are identified, all of the values then that we get from it. And now one thing I skipped over just in the interests of time is this customer happened to include some information that are against our policies. In this case, they included their email, they included their social security. So we've configured on this, the policy, we don't want any of that information. And so actually what was happened is behind the scenes, each of the models read that policy dynamically, redacted that information. So each time a model was called, it was actually redacting that information so that never went through the model. It wouldn't be promulgated or pushed forward into any other systems. In this case, it's all running on an endpoint device. But if you have this running on a server, you can be certain then that none of that information would get pushed into any other systems. We can see the full inference history and all of the data, each inference, the response, confidence scores where we actually are analyzing the logits and the probability distribution of those logits. We run everything with 0 temperature and 0 sampling. So it's always taking the top logit output from the model. And then you can even see some of the performance characteristics around it. And then finally, we create a whole bunch of artifacts from visualizations of the process all the way down to all of the extract keys that you get at the end, which you can then push through for an API. All right, so that is the process itself. We could keep running this. We could keep running it with new samples. You could picture this running on a whole bunch of different customer support agents' machines. They could all run this process locally without any information leaving their system. All of this is configuration data that's customizable and can be easily shared. But what I wanted to show you, the really cool part, is how you actually build this process. So we actually first built this very simple kind of prototype scenario in LLMWare in open source. It was about 100 lines of code leveraging high-level APIs in LLMWare with no UI. Today, it's 8 lines of no code, all running on a point-and-click Windows application. You can download this, run this on your machine, and in minutes, you can be creating these agents with no code. So you could take this process, now that we've created it and run it, you could run it as an API, pop it up to one of our servers. It'll then run it and return the results to you. So if you want to run a batch process, you want to be able to share it. You can then discover other APIs. But what I want to do is I want to go and show how this was created. Now, the way that the underlying agent engine runs, and it's working on this local machine, is everything is, the entire process is represented and generated as JSON configuration. The benefit of that then, again, it becomes really, really easy to export and to share this process. So just as an example, if you wanted to export this, you could build a copy of it. What this does is takes all the JSON configuration, the files that are included in it, packages it up as a zip file. You can do peer-to-peer sharing now because there's no executable code in that package. And there's obviously hash integrity checks done on each of those files. Or you can then easily take this and publish it up to a server so you can then execute and start running this. All of it done privately, locally, and self-hosted by an enterprise. But what I wanted to get into is the code editor. All right. This is the entire process, and this is exactly how I created it this morning. There is no code behind the scene. There is no customization. There are no Docker containers. There are no Python scripts. There's no pip install. Python is not even running on the machine that we are. It's a pure Windows machine, point and click, downloaded, executable. Here is the entire process. We call the sentiment service. As I mentioned, no actual instructions provided because it's an action model that's just giving us a generated output of sentiment and the key that classifies it. It's operating on a context that we define automatically, the stub or framework of we're going to be taking in that text input. That is the main input that we receive. We packaged in a file called customer table 1 that then produces a context. Once we run through each of the sentiment, emotions, rating, the extract model, we extract the customer name, which then generates a variable called customer name. We then build the database table through these two no-code lines, sucking in that CSV file. We infer the schema of it. We put it locally. We create that table as a SQLite database, as sort of a throwaway database running on device. We then query that database. And in querying that database, the longest prompt that we have here is we pull that variable name from this step into a natural language query of what is the customer level for this customer name. That gets converted dynamically into SQL, and then the information is retrieved from that database. We then do that again with their annual spend. So here we are. I know we're running out of time. 8 steps, no code, multiple models, all executing locally and privately with complex lookups across multiple underlying sources. Where we're going with this, this is just one example. There's 35 different services that can be orchestrated in this manner and really, really sophisticated RAG capabilities. So you can start analyzing, parsing, extracting, and manipulating, thousands of pages of information running locally or seamlessly being able to do it in conjunction with a Model HQ server as well. So that is the demo. There's a lot more. I wish that
Yeah, it's an
hopefully this brings
interesting
to life some of the
approach.
things we're working on.
I have one question. You said something about the models directly redact the data, the email, whatever it was, doesn't matter.
Yeah.
Does the model really do it
Yeah.
itself, or is it a process after or before the model?
So we have 10 different control points that we implement across all of our model classes within the base code that are fully configurable then by policy. And what that enables you to do then is to set controls at every single step of the underlying model lifecycle. Since it's all self-hosted, it's all running through this code. So if you say, I want to be able to redact certain things, if you say, if this happens, then I want every single model to change its behavior, react in a different way, I want to reroute it from one model to another, all of those can be defined as configurable policies. But yes, it is instantiated as the code, configurable by policy. It's not actually something happening in the model per se.
Okay, got it. I just want to be clear about that. Okay, thank you so much.
Great.
We